there is a quiet assumption woven so deeply into modern thought that it is rarely questioned at all, that Earth is special in the most fundamental way possible, not just rare, not just fortunate, but somehow optimal, the perfect balance, the precise mixture, the only place where life could truly unfold into awareness and reflection. And yet, when this assumption is held up to the light of careful observation, it begins to show hairline fractures, tiny inconsistencies that do not shatter the idea outright, but make it hum faintly with doubt. Earth supports life, undeniably, but support is not the same as design, and survival is not the same as harmony. Life here is resilient, yes, but also constantly under siege. Radiation storms, asteroid impacts, mass extinctions, runaway climate swings, oxygen poisoning events in the distant past. The history of life on this planet reads less like a carefully tuned system and more like a long series of narrow escapes. It raises an uncomfortable question that tends to linger just beneath the surface of celebration. Is Earth truly ideal for life, or merely sufficient? In astronomy, habitability is often discussed as if it were a checklist. Liquid water, a stable star, an atmosphere, a magnetic field. Earth satisfies these conditions, and so Earth becomes the template. But templates have a subtle flaw. They are shaped by the thing they are meant to describe. The criteria for habitability were not discovered first and then matched to Earth. They were reverse engineered from Earth itself, and that circular logic leaves room for a quiet contradiction. Perhaps Earth feels ideal only because life here adapted to its imperfections, not because those imperfections were necessary. When astronomers began detecting planets beyond the solar system, the initial surprise was not how rare Earth-like worlds were, but how common planets were overall. Thousands appeared where once there had been none. Some were larger than Earth, yet rocky. Some orbited stars that would burn steadily for tens or even hundreds of billions of years, far longer than the Sun's lifespan. Some possessed conditions that, on paper, appeared calmer, more stable, less violent than Earth's restless environment. Slowly, almost reluctantly, a new category entered scientific language. Worlds that might be even better for life than Earth. Better is a dangerous word. It implies hierarchy, optimization, comparison. And yet, scientists did not use it casually. They used it because the data nudged them there. Consider Earth's star. The Sun is middle-aged, moderately stable, but not especially long-lived. It will brighten with time, rendering Earth uninhabitable long before it ever explodes. Other stars, smaller, cooler, longer burning, offer planetary systems vastly more patient. A planet orbiting such a star might enjoy stable conditions for periods that dwarf the entire history of life on Earth. The implication is subtle but profound. Intelligence elsewhere might have far more time to develop, refine, and endure. Earth's gravity, too, is a compromise. Strong enough to hold an atmosphere, weak enough to allow gases to escape. A slightly stronger gravitational pull could retain thicker atmospheres, better radiation shielding, more stable climates. Earth walks a narrow ridge between retention and loss. That ridge has not always been kind. Atmospheric composition has shifted violently across epochs, triggering extinctions and reinventions. From a purely biological perspective, these upheavals are not signs of elegance. They are signs of fragility endured. Even water, the most celebrated ingredient of life, behaves chaotically here. Oceans rise and fall, ice sheets advance and retreat, sea levels swing dramatically. On other worlds, models suggest oceans that are deeper, more uniform, less exposed to rapid evaporation or freezing, water that lingers rather than lashes. Such worlds might offer a gentler evolutionary canvas where complexity accumulates without being repeatedly erased. None of this implies that Earth failed, only that it might not be exemplary. Life here has not thrived because conditions were perfect, but because life is extraordinarily adaptable. It bends, it compromises, it endures, and endurance, while admirable, is not the same as flourishing. A tree growing from a crack in concrete is alive, but no one would call the concrete an ideal forest. The deeper discomfort arises when this realization brushes against a long-standing philosophical instinct, the idea that our existence implies special conditions tailored for us. This instinct appears in the anthropic principle, which suggests that the universe must allow for observers, because observers exist. It sounds explanatory, but it subtly sidesteps the question. It does not say Earth is the best place for life. It only says that wherever observers arise will seem suitable to them. Suitability, in this view, is not evidence of optimization, only of survival bias. This distinction matters, because if Earth is merely one viable solution among many, perhaps not even the most forgiving one, then the universe may be far more generous to life than previously assumed. Not more mystical, more permissive. A landscape filled not with miracles, but with options. As telescopes like the Kepler Space Telescope quietly collected years of starlight, they revealed planetary systems that did not resemble our own neat architecture. Many were denser, more crowded, more stable. Some planets circled their stars in tidal locks, presenting the same face forever, once thought hostile, now reconsidered as potentially stable climate systems with broad, habitable zones. Others resided in regions where radiation levels, stellar flares, and orbital chaos were surprisingly subdued. Each discovery chipped away at the comforting narrative that Earth sits at the pinnacle of possibility. Instead, a more unsettling image emerged. Earth as an early draft, a workable version, a place where life managed to take hold, but under constant pressure, always one cosmic accident away from erasure. And yet, perhaps this pressure shaped something essential. Perhaps fragility sharpened awareness. Perhaps instability accelerated adaptation. Or perhaps that belief is another story we tell ourselves to make difficulty feel necessary. There is no conclusion here, only an opening. If planets exist that offer life calmer skies, longer timelines, thicker protection, gentler cycles, then intelligence there may arise without the scars that mark Earth's history. Such intelligence might not be louder or brighter. It might simply be older, more patient, less hurried, and that leads to a final, lingering question that refuses to settle. If Earth is not the best possible home for life, but merely the one we happen to wake up in, what does that say about the nature of reality itself, and about the places where consciousness may already be waiting, quietly, under more forgiving stars? Stars are often spoken of as if they were simply lamps, sources of light and heat that planets happen to circle. But this simplification hides a deeper imbalance. A star is not a passive backdrop. It is an active participant in the story of life, shaping not only climate and chemistry, but the very tempo at which existence is allowed to unfold. And when Earth's star is examined without sentiment, it begins to feel less like a benevolent guardian and more like a ticking clock. The sun is stable by human standards. It rises and sets with comforting regularity, burns without catastrophic flares most of the time, and has provided billions of years of relative calm. Yet in cosmic terms, the sun is hurried. It is brighter than many stars capable of hosting planets, and it ages faster than they do. With each passing million years, its output slowly increases, nudging Earth toward a future where oceans will evaporate and atmospheres will thin. Life here has not been granted unlimited time. It has been placed on a schedule. Elsewhere in the galaxy, smaller stars burn differently. Red dwarfs, once dismissed as hostile, glow faintly and steadily for spans of time that challenge intuition. Trillions of years, long after stars like the Sun have faded into remnants, these dim suns continue their quiet output. Planets orbiting them would experience not a brief window of habitability, but an almost unthinkable duration of stability. From the perspective of life, time is not a luxury, it is a resource. Evolution does not rush. Consciousness does not bloom on command. It accumulates, layer by layer, mistake by mistake, generation by generation. Earth's biological history reveals how constrained time can be. Complex multicellular life appeared late. Intelligence arrived even later. And again, progress was reset by mass extinctions, asteroids, volcanic winters, climate collapses. Each reset erased countless evolutionary experiments. Each recovery consumed millions of years. On a planet orbiting a longer-lived, calmer star, these interruptions might be rarer or less severe. Intelligence there could develop without being repeatedly pushed back to the starting line. There is a subtle discomfort in this idea. It suggests that Earth's story may be unnecessarily dramatic, that our struggles were not prerequisites, but consequences of circumstance. The familiar narrative frames hardship as a forge, shaping resilience and ingenuity. But science does not require this framing. Biology only requires continuity, stability, time uninterrupted long enough for complexity to persist. Astronomers began to suspect this when stellar demographics became clearer. Most stars in the Milky Way are smaller and cooler than the Sun. Many host planetary systems tightly bound and dynamically calm. These stars do not blaze brightly, but they do not rush toward transformation either. Their constancy offers something Earth has never known: patience on a cosmic scale. Of course, red dwarf stars pose challenges: early flares, tidal locking, radiation bursts. These factors were once considered disqualifying. Yet newer models complicate the picture. Thick atmospheres could redistribute heat. Strong magnetic fields could shield radiation. Oceans could act as thermal reservoirs, smoothing extremes. What once looked hostile now appears merely different. Another reminder that Earth-based intuition often fails when applied universally. The idea of better worlds does not require perfection. It requires fewer interruptions, fewer existential threats arriving at random intervals. Earth's position in the galaxy has exposed it to asteroid belts, supernova shockwaves, and gravitational perturbations. None of these were chosen. They were inherited. Other planetary systems appear quieter, tucked into regions of space where chaos is less frequent. Life there might evolve under skies that rarely threaten annihilation. Time also shapes psychology. A civilization that develops under a long-lived star may not experience the same urgency that defines humanity. When extinction feels distant rather than imminent, priorities shift. Expansion may seem unnecessary, exploitation less tempting. The pressure to act before the clock runs out would simply not exist. Intelligence might mature slowly, contemplatively, without the constant shadow of collapse. Earth's star, by contrast, imposes subtle anxiety, not consciously, but structurally. Life here has always existed under deadlines imposed by geology, climate, and stellar evolution. Even now, the sun's gradual brightening ensures that Earth's habitability is temporary. Not tomorrow, not soon, but inevitably. This knowledge sits beneath scientific discourse like a quiet hum. Time is limited. The discovery of thousands of exoplanets reinforce this realization. Data from missions such as the Kepler Space Telescope revealed planetary systems where stars and planets coexist in configurations far more enduring than our own. Later observations refined this understanding, suggesting that Earth-like conditions may persist far longer elsewhere. Not because those systems are miraculous, but because they are less hurried. What emerges is not envy, but disorientation. Humanity has long treated Earth as the gold standard, yet the universe does not appear to have aimed for standards at all. It produces variety. Some configurations are volatile, others are serene. Earth belongs to the former category more than we like to admit. Its beauty is inseparable from its instability, and yet, instability may have accelerated something intangible. Awareness. Fragility makes perception sharper. When environments are unforgiving, adaptation favors attentiveness. Perhaps consciousness flourished here because survival required constant negotiation with uncertainty. Or perhaps this is merely a comforting story, constructed after the fact. The deeper question is not whether Earth is worse or better, but whether our criteria are misplaced. We often equate intensity with importance, drama with significance, but the universe may value duration over intensity, continuity over struggle. In that case, the most advanced forms of life may arise not in places like Earth, but in environments so gentle they leave little trace of conflict. Somewhere beneath a dim red sky, orbiting a star that barely changes over billions of years, life may have had the luxury of forgetting fear. Intelligence there might not look outward with urgency. It might not broadcast its presence. It might simply exist, layered with memory, unpressured by extinction. If that is true, then Earth's story is not central. It is illustrative, a case study in what life can do when time is scarce and danger is frequent. Other stories may be unfolding more quietly, beyond our detection, under stars that do not demand haste. And the thought lingers, unresolved and persistent. If intelligence elsewhere has been given more time than we can imagine, what kinds of questions are they asking now? And how different might their understanding of reality be, shaped not by urgency, but by patience? Gravity is one of those forces that fades into the background of daily awareness. It is always present, always acting, yet rarely considered as anything other than a constant. On Earth, gravity feels natural, inevitable, unquestioned. Bodies move the way they do because this is the only way they have ever moved. But when gravity is examined not as familiarity, but as a variable, another quiet contradiction begins to surface. One that reshapes the idea of what a life-friendly world might truly look like. Earth's gravity is moderate, strong enough to hold oceans and air, weak enough to allow mountains to rise and rivers to flow. It sits at a delicate midpoint, often celebrated as ideal. Yet moderation does not automatically mean optimization. From a biological perspective, gravity is not merely a physical constraint. It is a sculptor. It shapes anatomy, circulation, skeletal strength, even the maximum size and complexity of organisms. And small changes in gravity can have profound consequences. On worlds slightly larger than Earth, so-called super-Earths, gravity would be stronger, but not crushing. Early assumptions framed such planets as hostile, imagining immense pressures and flattened life forms. But more careful modelling paints a subtler picture. A modest increase in gravity could produce thicker atmospheres, which in turn provide better insulation against radiation and temperature extremes. Denser air distributes heat more evenly, reduces weather volatility, and shields surface life from cosmic events that regularly batter Earth. Earth's atmosphere is surprisingly fragile. Over geological time, significant portions of it have escaped into space. Solar wind stripped early gases away before the magnetic field fully formed. Even now, lighter elements continually leak into the void. This slow erosion is invisible to human timescales, but decisive over billions of years. A planet with stronger gravity would retain its atmosphere more effectively, preserving chemical stability across epochs. Life there would not need to repeatedly adapt to dramatic atmospheric shifts. Stronger gravity also influences water. On Earth, water is restless. It evaporates easily, freezes readily, cycles violently. Increased gravity raises boiling points and stabilizes liquid phases. Oceans on such worlds might be deeper, calmer, less prone to catastrophic evaporation or global freezing. Instead of oscillating between extremes, water would linger, patient, persistent, reliable. From an evolutionary standpoint, this reliability matters. Life thrives when conditions repeat often enough to be learned. There is an instinctive resistance to this idea. Stronger gravity sounds oppressive, limiting, uncomfortable. But discomfort is a human projection. Life adapts to what is normal. On a heavier world, organisms would evolve stronger structures, more efficient circulation, perhaps even more compact and resilient forms. What feels restrictive to imagination may be liberating to biology, offering stability in exchange for effort. Earth's own evolutionary history hints at this trade-off. Larger animals struggled under gravity as oxygen levels fell and climates shifted. Complexity was repeatedly pruned back, not because it was unviable, but because the environment could not support it consistently. On a planet where gravity and atmosphere work together to buffer change, complexity might persist rather than collapse. Intelligence there would not need to rebuild itself so often. Gravity also governs geological behavior. Stronger gravity compresses planetary interiors, potentially slowing plate tectonics. Earth's tectonic activity renews landscapes, but it also triggers mass extinctions through volcanism and climate disruption. Slower tectonics could mean fewer catastrophic events, longer-lived continents, and ecosystems with uninterrupted histories stretching across unimaginable spans of time. Stability again emerges as a recurring theme. None of this implies that Earth's gravity is wrong, only that it is one of many viable settings, not a universal benchmark. Earth feels balanced because life here learned to dance with its constraints, but balance achieved through adaptation is different from balance designed into the system. The former is reactive, the latter is permissive. As astronomers catalogued exoplanets, they found that rocky worlds slightly larger than Earth are not rare exceptions. They are among the most common planetary types in the galaxy. Many orbit within habitable zones, receiving gentle stellar energy while benefiting from their greater mass. For a time, these worlds were overlooked, dismissed as borderline cases. But as understanding deepened, they began to look less like compromises and more like opportunities. The question then shifts subtly. Not, can life exist there? But how well could life persist there? Earth's biosphere has survived, but at great cost. Extinction is woven into its history. On worlds where gravity stabilizes atmosphere, oceans, and climate, extinction might be rarer, slower, less absolute. Life would have time to recover without starting from near nothing. There is also a psychological implication that is easy to miss. On Earth, gravity encourages verticality. Life rises, climbs, stretches upward. It competes for light. On heavier worlds, growth might favor horizontal complexity instead. Dense networks, layered ecologies, interconnected systems rather than towering dominance. Intelligence emerging from such environments might prioritize integration over expansion, continuity over conquest. Human imagination often associates advancement with escape, from gravity, from planetary limits, from constraint itself. But perhaps this is another narrative shaped by scarcity. On a world where gravity provides protection rather than threat, escape might feel unnecessary. The sky would not represent freedom. It would represent distance. Earth's gravity has always allowed loss. Atmosphere lost. Water lost. Heat lost. Even now, the planet cools, slowly bleeding energy into space. On heavier worlds, retention replaces loss as the defining pattern. Energy lingers. Chemistry stabilizes. Change slows. From the standpoint of life, slowing change is not stagnation. It is opportunity. These ideas remain grounded in real astrophysical models and planetary science, discussed cautiously within academic literature. They do not promise paradise. They suggest something quieter. Conditions where life is less frequently interrupted, less often erased, less compelled to start over. Earth's story is dramatic because it has had to be. Gravity here neither fully protects nor fully confines. It permits just enough chaos to keep life alert. But alertness is not peace. It is readiness, somewhere beyond the reach of current telescopes, orbiting a star that does not hurry. There may be a planet whose gravity holds its world together more gently than Earth ever could. Life there may move more slowly, think more slowly, and endure far longer. Not because it is superior, but because the ground beneath it is more forgiving. And the question drifts forward, unresolved and unsettling. If intelligence arises more easily in environments that resist catastrophe rather than provoke it, then what does that suggest about the kind of intelligence Earth was shaped to produce, and the kinds that may already exist elsewhere under heavier skies, feeling no need to look away from their world at all? Water is so deeply associated with life that it often escapes scrutiny. It is treated as a simple requirement, a box to be checked, a presence to be confirmed. Liquid water exists, therefore, life may follow. But this assumption hides a more unsettling possibility, that water's mere existence is not enough, and that the way water behaves on a planet may matter just as much as whether it is present at all. On Earth, water is restless. It circulates endlessly between ocean and sky, freezing, boiling, eroding, dissolving, reshaping everything it touches. This restlessness is often praised as a virtue. It fuels weather systems, distributes nutrients, sculpts landscapes. Yet, it is also destructive. Floods erase ecosystems. Ice ages grind continents. Droughts collapse civilizations. Earth's water cycle is not gentle. It is energetic, volatile, and frequently unforgiving. From a biological perspective, volatility is not inherently beneficial. Life adapts to patterns, not surprises. Stability allows complexity to accumulate. When environments fluctuate too violently, evolution becomes reactive rather than exploratory. Organisms optimize for survival rather than refinement. Earth's long history of abrupt climate shifts suggests that water here has often acted as a destabilizing force rather than a nurturing one. Planetary science offers alternatives. Models of larger, slightly cooler worlds suggest oceans that behave very differently. Deeper oceans, held more tightly by gravity, slower evaporation, reduced temperature swings, less dramatic seasonal change. On such planets, water may linger in liquid form with remarkable consistency, neither retreating into ice nor vanishing into vapor. Instead of cycling violently, it would remain present, patient, persistent, reliable. These worlds are sometimes referred to as ocean planets or water-rich super-Earths. They are not speculative fantasies. They emerge naturally from simulations of planetary formation and migration. Many appear to possess vast global oceans, far deeper than Earth's, with pressures that prevent water from easily transitioning into ice or gas. From above, such worlds might look monotonous. From within, they might be extraordinarily stable. Stability reshapes evolution. In calm oceans, ecosystems could persist for immense spans of time without interruption. Nutrient cycles would be slower, but more predictable. Chemical gradients would endure. Life would not need to repeatedly adapt to drying continents or advancing ice sheets. Instead of constant reinvention, evolution could favor long-term specialization, symbiosis, and refinement. There is an intuitive resistance to this idea. Earth's land-ocean contrast feels essential. Shores, tides, estuaries, these are often cited as crucibles for complexity. And it is true that interfaces encourage diversity. But interfaces need not be violent to be productive. Gentle gradients, persistent boundaries, and slow currents can also generate complexity, perhaps more sustainably than environments shaped by catastrophe. Earth's own history reveals how often water-driven change erased progress. Entire branches of life vanished during periods of rapid ocean acidification. Ice ages repeatedly compressed habitable zones, forcing migrations and extinctions. Sea level fluctuations drowned coastal ecosystems just as frequently as they exposed them. These events did not create life, they tested it, often harshly. On a calmer water world, life might experience far fewer resets. Complexity could accumulate without being repeatedly pruned. Intelligence emerging in such environments would inherit not a history of near annihilation, but one of continuity. Memory would stretch further back. Cultural inheritance might not be punctuated by collapse. The past would feel less fragile. Water chemistry also matters. Earth's oceans are salty, reactive, chemically dynamic. Their composition has shifted dramatically over time, sometimes poisoning existing life forms. On other planets, ocean chemistry might be more buffered, less prone to abrupt change. Stable pH, consistent mineral content, and slower geochemical cycling would reduce the evolutionary pressure imposed by chemical volatility. None of this suggests that Earth's water is wrong. It suggests that Earth's water is active, energetic, demanding. Life here did not simply exist in water, it survived it. And survival, while impressive, is not synonymous with optimal conditions. There is also a psychological dimension worth considering. On Earth, water is associated with uncertainty, storms, floods, drowning. Even at a subconscious level, it represents both life and threat. On a planet where water rarely behaves violently, this association might never form. Water would not inspire fear or reverence. It would simply be there. This absence of fear matters. Fear shapes cognition. It accelerates decision-making, prioritizes short-term survival, narrows focus. Intelligence that evolves without constant environmental threat may develop differently. Less urgency, less obsession with control, more attention to continuity rather than defense. On such worlds, consciousness might unfold without the constant undertone of anxiety that shadows Earth's evolutionary story. Earth's continents amplify water's volatility. Rivers carve aggressively. Mountains force rainfall extremes. Tectonics raise and drown land repeatedly. On worlds dominated by deep oceans and minimal topography, these amplifiers would be absent. Water would not be forced into dramatic motion. It would settle. Some researchers have raised concerns about nutrient availability on ocean worlds. Without exposed land, how would minerals enter the biosphere? But hydrothermal vents offer one answer. On Earth, some of the oldest and most stable ecosystems exist around such vents, entirely independent of sunlight and surface cycles. On ocean planets, similar systems could be far more widespread and long-lived, supporting complex life in stable darkness. This returns the narrative to a recurring theme: continuity. Earth's life has been resilient precisely because it had to be. But resilience is costly. It requires constant adaptation, constant vigilance. In environments where water behaves gently rather than aggressively, life may not need to be resilient. It may simply be persistent. The discovery of planets with vast, stable oceans complicates the idea that Earth's surface conditions represent an ideal. They suggest instead that Earth is one expression among many, one where water acts as both creator and destroyer. Other expressions may favor creation with far less destruction. As observations improve, especially through instruments capable of analyzing atmospheric and surface conditions indirectly, these possibilities move from abstraction toward plausibility. The universe does not appear to limit itself to one way of supporting life. It experiments, and the thought drifts onward, unresolved and quietly unsettling. If intelligence can emerge in worlds where water never needed to threaten life, never needed to erase it, then what forms of awareness might arise there, unburdened by fear of flood or freeze, shaped not by survival against water, but by coexistence with it? An atmosphere is often described as a blanket, but that metaphor is misleading. Blankets are passive. They rest quietly, offering warmth without resistance. A planetary atmosphere, by contrast, is a battlefield, an active interface where radiation, particles, chemistry, and magnetic forces collide. Earth's atmosphere has allowed life to exist, but it has never truly rested. It has shifted, thinned, thickened, poisoned, and purified itself again and again, each transformation leaving a mark on everything living beneath it. Early in Earth's history, the atmosphere was hostile to the life forms that would later depend on it. Oxygen, now essential, was once a toxin. Its sudden rise nearly extinguished the anaerobic world that preceded it. Later, fluctuations in greenhouse gases triggered global freezes and hothouse conditions. Even today, the atmosphere remains precariously balanced, sensitive to relatively small changes in composition. From a distance, it appears protective. From within, it behaves like a system perpetually on edge. This instability invites a quiet comparison. On larger planets with stronger gravity, atmospheres are harder to lose. Gases linger, chemical ratios change more slowly. The sky becomes less reactive, less vulnerable to sudden stripping by stellar winds or radiation bursts. On such worlds, the atmosphere may function not as a battlefield, but as a buffer, absorbing shocks rather than amplifying them. Earth's magnetic field provides partial protection, but it is neither constant nor guaranteed. It has weakened, reversed, and fluctuated across geological time. During periods of weakness, the atmosphere was exposed to increased solar radiation, accelerating loss and altering chemistry. These episodes left biological scars that evolution was forced to navigate. A planet with greater mass and a stronger, more stable magnetic field would experience fewer such disruptions. Its atmosphere would not merely exist, it would endure. Radiation is an often overlooked constraint on life. Earth's surface is continually bathed in cosmic rays, solar particles, and high-energy photons. Most are deflected or absorbed, but not all. Over time, radiation damages DNA, increases mutation rates, and subtly shapes evolutionary pathways. Some mutation is beneficial. Too much becomes destabilizing. On worlds with thicker atmospheres, radiation levels at the surface could be dramatically reduced, creating an environment where biological change proceeds more slowly and predictably. Predictability matters. Life thrives when feedback loops are gentle. When change arrives gradually enough to be incorporated rather than resisted. Earth's atmospheric history reveals repeated moments where change arrived abruptly instead. Volcanic outgassing darkened skies. Impacts filled the air with debris. Rapid shifts pushed ecosystems beyond recovery thresholds. Each event selected for survival, not elegance. In contrast, models of so-called superhabitable planets often emphasize atmospheric thickness as a key advantage. Not suffocating density, but protective mass. Enough to distribute heat evenly, retain moisture, and shield against radiation. On such planets, weather systems might exist without becoming catastrophic. Storms without global consequences. Winds without planetary scars. Earth's weather is dramatic because its atmosphere is thin enough to be easily disturbed. Temperature gradients drive violent motion. Small imbalances cascade into extremes. Hurricanes, droughts, and jet streams are expressions of a system that is constantly redistributing energy. A denser atmosphere would dampen these gradients, smoothing transitions rather than amplifying them. Climate would still change, but slowly. This slowness would ripple outward into biology. Organisms would not need to brace for rapid swings. Ecosystems could remain geographically stable for far longer. Migration would be a choice, not a necessity. Specialization could deepen without risking collapse. Intelligence emerging under such skies would inherit continuity rather than disruption. There is also chemistry to consider. Earth's atmosphere participates aggressively in chemical reactions. Oxygen oxidizes. Ultraviolet radiation splits molecules. Reactive gases appear and disappear. These processes drive life's chemistry, but they also impose constant stress. On planets with different atmospheric compositions, higher pressures, altered ratios, persistent cloud layers, chemistry might proceed along steadier pathways. Life would adapt to a calmer chemical rhythm. Clouds themselves may play an underappreciated role. Thick, persistent cloud cover can reflect radiation, stabilize temperatures, and protect surfaces from stellar activity. Earth's cloud systems are dynamic and uneven, sometimes cooling, sometimes warming, often unpredictable. On other worlds, global cloud layers could act as permanent shields, creating surface conditions that rarely fluctuate beyond narrow bounds. Observational astronomy has begun to glimpse hints of such atmospheres. Instruments aboard the James Webb Space Telescope have already detected atmospheric signatures around distant exoplanets. Water vapor, carbon dioxide, complex clouds. Each spectrum is incomplete, indirect, and cautious. Yet together, they suggest that Earth's atmospheric configuration is not universal. It is one option among many. The implication is not that Earth is poorly designed, but that it is energetically active. Its atmosphere participates fully in planetary processes. It responds, reacts, amplifies. This activity may have accelerated evolution, pushing life toward rapid innovation. But acceleration comes with risk. Speed invites error. Stability invites refinement. Human psychology reflects this tension. Earth's atmosphere has always been something to fear. Storms gather without warning. Skies darken. Air itself becomes a threat. These experiences shaped myth, culture, and caution. They taught awareness, but also anxiety. On planets where the sky rarely threatens, intelligence might evolve without associating the heavens with danger. The atmosphere would not be something to watch, it would be something to trust. Trust changes behavior. It encourages patience, long-term planning, deferred gratification. A civilization born beneath a reliably protective atmosphere might not feel compelled to exploit its environment aggressively. Resource management would unfold over longer timescales. Expansion would feel optional rather than urgent. Earth's thin sky has always reminded life of its vulnerability. Breath itself depends on a fragile layer only a few kilometers thick. This fragility sharpened survival instincts, but it may also have imposed limitations on how intelligence perceives the universe. Always aware, always alert, always preparing for disruption. On worlds with thicker, more forgiving atmospheres, the sky might feel permanent, not infinite, but dependable. Life there would grow under the assumption of continuity rather than collapse. Knowledge could accumulate without being repeatedly lost. Memory could extend deeper into the past. The universe does not appear to privilege drama. It allows it, but it does not require it. Earth's atmosphere participates in drama because it is thin, active, and responsive. Other atmospheres may quietly absorb the universe's indifference without passing it along. And so the thought remains suspended, unresolved. If intelligence flourishes most fully where the sky itself offers protection rather than challenge, then what kinds of minds might already exist beneath thicker heavens? Minds shaped not by fear of the air, but by long familiarity with its quiet reliability? Temperature is often treated as a simple number, a narrow band between freezing and boiling where life may exist. But temperature is not a static property. It is a rhythm, a pattern of variation over days, seasons, millennia. And on Earth, that rhythm has never been gentle. It surges and collapses, drifts and snaps back, oscillating between extremes that have repeatedly pushed life to the brink. Earth's climate has always been unstable on long timescales. Ice ages arrive not as anomalies, but as recurring features. Warm periods bloom and fade. Entire continents alternate between being buried under kilometers of ice and covered in dense forests. These swings are not subtle. They reshape oceans, alter atmospheric chemistry, and redraw the boundaries of habitability again and again. Life survives by retreating, adapting, or vanishing. From a distance, this instability is often romanticized. It is described as a driver of innovation, a pressure that forces evolution to explore new solutions. But pressure also constrains. It narrows possibilities. When environments change too quickly, complexity becomes fragile. Systems that take millions of years to assemble can be dismantled in centuries. Intelligence, once it appears, is not immune to this fragility. Planetary science suggests that Earth's temperature volatility is not inevitable. It arises from a particular combination of factors: axial tilt, orbital eccentricity, continental arrangement, ocean circulation, and atmospheric sensitivity. Alter any one of these, and the rhythm changes. On other worlds, the rhythm may be slower, softer, more forgiving. Consider axial tilt. Earth's tilt gives rise to seasons, which in moderation enrich ecosystems. But even small variations in tilt over time have amplified climate swings dramatically. On planets with more stable axial orientations, seasons might be mild or nearly absent. Temperature gradients would flatten. The planet would not lurch between extremes, but hover within a narrower thermal range for eons. Orbital shape matters as well. Earth's orbit is slightly elliptical, contributing to long-term climate cycles. Other planets may follow nearly perfect circles, receiving consistent energy year after year. Without periodic surges or deficits of stellar input, climate would remain steady. Ice would not advance unexpectedly. Heat would not accumulate uncontrollably. The system would breathe slowly. Oceans play a role too. Earth's oceans redistribute heat, but they also interact with continents in complex ways that can destabilize climate. On planets dominated by deep global oceans or with simpler land distributions, heat transport may be smoother, less prone to sudden disruption. Temperature would become a background condition rather than a recurring crisis. The consequence of such stability is profound. Life would not need to be constantly prepared for environmental reversal. Evolution would proceed along longer, uninterrupted paths. Traits favoring efficiency, cooperation, and longevity could persist without being periodically erased by climate catastrophe. Complexity would not be a gamble, it would be an investment. Earth's history offers a stark contrast. Each ice age compressed habitable zones, forcing species into refuges. Each warming period reshaped coastlines and drowned ecosystems. Intelligence emerged late, after countless resets had already occurred, and even then, it arose on a planet whose climate remains precariously sensitive. This sensitivity influences behavior. Societies here learn to store food, migrate, adapt quickly, exploit resources before conditions change. Urgency became embedded in culture. Time felt scarce. On a planet with stable temperatures across geological timescales, urgency might never become dominant. Planning could extend across generations without fear that the environment itself would betray those plans. Temperature stability also affects chemistry. Reaction rates depend on heat. On Earth, fluctuating temperatures accelerate and decelerate biological processes unevenly, stressing systems optimized for particular ranges. On worlds with stable thermal environments, biochemical processes could remain finely tuned without constant recalibration. Life would not need to hedge against extremes. It would settle into equilibrium. There is an intuitive belief that variation is necessary for richness. That monotony breeds stagnation. But variation does not need to be violent to be meaningful. Subtle gradients, slow cycles, and gentle oscillations can produce diversity without destruction. Earth's climate variations are not subtle. They are abrupt enough to erase entire evolutionary trajectories. The idea of a planet where climate remains within a narrow, life-friendly band for billions of years challenges a deeply ingrained narrative. It suggests that Earth's dramatic past may not be a universal template, that intelligence does not require repeated brushes with extinction to arise. That consciousness might flourish most fully where the environment rarely demands survival at all costs. From an observational standpoint, such planets are difficult to identify. Climate stability leaves few dramatic signatures. Ice ages carve scars. Atmospheric collapses leave chemical fingerprints. Calm leaves little evidence. The quietest worlds may be the hardest to notice. their histories written in continuity rather than disruption. Yet theoretical models consistently indicate that such worlds should exist. Planets with low axial variability, circular orbits, thick atmospheres, and deep oceans naturally dampen thermal extremes. None of these features violate known physics. They are combinations the universe can assemble without effort. Earth simply did not receive them all at once. This realization reframes the idea of habitability. It is not enough for a planet to allow life. It must allow life to persist without constant interruption. Earth barely meets this higher standard. It allows life, but rarely leaves it alone. Temperature stability shapes psychology as well. On Earth, weather is a constant concern. Heat waves and cold snaps threaten crops and infrastructure. Climate anxiety, in various forms, has always existed. On a planet where temperature rarely deviates, the environment fades into the background of awareness. Attention shifts inward, toward relationships, ideas, and long-term understanding rather than immediate adaptation. Such a shift could transform intelligence itself. When survival is not the primary challenge, cognition explores different questions. Meaning replaces endurance. Understanding replaces control. A stable climate does not guarantee wisdom, but it removes a powerful source of distraction. Earth's climate taught life to be reactive, to respond quickly, to innovate under pressure. That legacy is written into biology and culture alike. But reaction is not reflection. Speed is not depth. Other worlds may have traded urgency for continuity, drama for patience. Somewhere, perhaps orbiting a star that barely changes and turning on an axis that hardly wobbles, there may be a planet whose temperature has remained kind for billions of years. Life there may never have known ice ages or runaway heat. Intelligence there may have arisen without ever fearing environmental betrayal. And the question lingers, unresolved and quietly unsettling. If the deepest forms of awareness require long, uninterrupted stability rather than repeated crisis, then what kinds of minds might emerge on worlds where temperature itself has always been trustworthy? And how unfamiliar might their way of understanding reality be, shaped not by survival against the climate, but by living within it? The surface of a planet is never truly still. Even when it appears calm, it is being shaped from below by forces moving far more slowly than perception allows. On Earth, this hidden motion is expressed through the plate tectonics, a restless rearrangement of continents that has sculpted mountains, opened oceans, and erased entire worlds. It is often described as essential to life, a recycling system that renews the planet. But renewal, like all forms of transformation, comes at a cost. Earth's tectonic activity is vigorous. Plates collide, tear apart, and slide past one another with unpredictable intensity. This motion releases nutrients, regulates atmospheric carbon, and creates diverse habitats. Yet, it also triggers mass extinctions. Supervolcanoes darken skies. Continental collisions alter ocean currents and climate. Entire ecosystems vanish not because they failed to adapt, but because the ground beneath them shifted too abruptly. From the perspective of life, tectonics is a double-edged phenomenon. It enables habitability over long timescales, but repeatedly disrupts continuity on shorter ones. Evolution proceeds, only to be reset by geological violence. Complexity rises, only to be flattened. Earth's biosphere has been rebuilt so many times that its deep past feels fragmented, incomplete, punctuated by loss. Planetary science suggests that this level of tectonic activity is not universal. On slightly larger planets, increased gravity and internal pressure may alter how heat escapes from the interior. Instead of fast-moving plates, heat may dissipate more evenly through the mantle. The surface would still change, but slowly, almost imperceptibly. Mountains would rise without catastrophe. Continents would drift like thoughts rather than collide like weapons. On such worlds, geology would not dominate biology. The land would not be in constant negotiation with destruction. Ecosystems could persist in place for hundreds of millions of years without being forced to migrate or vanish. Rivers would not be rerouted by sudden uplift. Coastlines would not drown overnight. The planet would evolve, but without trauma. Earth's geological drama shaped life into a survivor. Species that thrived were those capable of rapid adaptation, dispersal, and resilience. Intelligence, when it appeared, inherited this legacy. It learned to anticipate collapse, to build quickly, to extract resources before the landscape changed again. These behaviors are often mistaken for universal traits of intelligence, but they may simply be responses to an unstable ground. On a planet with slower tectonics, intelligence might develop differently. With continents that endure, history would remain geographically anchored. Cultural memory would not be erased by floods of lava or advancing ice sheets triggered by tectonic shifts. Cities could persist in the same locations for immense spans of time. Knowledge would accumulate without being repeatedly lost to geological upheaval. The chemistry of such worlds would also differ. Earth's tectonics recycle minerals through subduction and volcanism, but this recycling is uneven and sometimes catastrophic. On calmer planets, surface chemistry might stabilize. Nutrient availability would change slowly, allowing ecosystems to optimize rather than constantly reconfigure. Life would not need to exploit resources aggressively. It could plan for replenishment that actually arrives. There is a common assumption that tectonics is required to regulate climate. On Earth, it plays a role in controlling carbon dioxide levels through long-term feedback loops. Without it, the atmosphere might drift toward extremes. But this is only one solution among many. Thick atmospheres, deep oceans, and alternative chemical cycles could perform similar regulatory functions without violent surface disruption. Stability does not require collision. Earth's interior heat escapes through dramatic expressions, eruptions, earthquakes, rifts. On other planets, that heat might leak quietly. Instead of explosive volcanism, there could be widespread, gentle resurfacing. Instead of earthquakes, slow deformation. The surface would change, but life would hardly notice. This distinction matters because catastrophe leaves scars not only on ecosystems, but on cognition. Repeated exposure to existential threat shapes how intelligence understands time, risk, and meaning. Earth's civilizations arose on a planet that regularly reminded life of its impermanence. Ruins are common here. Continuity is rare. On worlds where the ground itself is reliable, impermanence may not dominate awareness. The future would feel less uncertain. Long-term projects would feel rational rather than hopeful. Knowledge could be preserved without extraordinary effort. History would not feel fragile. There is also an aesthetic implication. Earth's dramatic landscapes, towering mountains, deep trenches, jagged faults, are products of violence. They inspire awe because they testify to power and instability. On calmer planets, landscapes might appear subdued by comparison. Rolling terrains, shallow seas, gradual gradients, beauty would emerge from subtlety rather than extremity. Human imagination often equates drama with significance, but significance does not require spectacle. A world that changes slowly may be less visually striking, but far more conducive to sustained complexity. Life there would not need to rebuild after catastrophe. It would refine. Observational evidence for such worlds is indirect, but theoretical models consistently allow for them. Planets with higher mass, different compositions, or alternative heat transport mechanisms naturally exhibit reduced tectonic violence. These are not exotic exceptions. They are expected outcomes of planetary diversity. Earth's tectonic restlessness has been framed as a gift. But perhaps it is simply a condition, one that life learned to endure rather than one that life required. The difference is subtle, but it reshapes how Earth's place in the universe is understood. If intelligence elsewhere arose on a planet where continents drifted so slowly that generations barely noticed change, then time itself would be experienced differently. History would feel continuous rather than episodic. Collapse would not be assumed. Progress would not feel urgent. Earth taught life to be alert, to adapt quickly, to prepare for loss. Other worlds may teach life to be patient, to invest deeply, to trust the ground beneath it. And so, the question lingers, unresolved and quietly destabilizing. If intelligence grows most fully where the planet itself does not repeatedly intervene with violence, then what kinds of civilizations might arise on worlds where geology whispers instead of shouts? And how different might their understanding of permanence be, shaped by a surface that rarely betrays them? At some point, the discussion drifts beneath landscapes, atmospheres, and climates, and settles into something quieter and more fundamental. Not where life exists, but what life is made of. On Earth, biology follows a familiar script: carbon chains, water as solvent, DNA and RNA carrying information, proteins folding into precise shapes. This chemistry feels inevitable, as though the universe itself selected it deliberately. Yet, inevitability, once again, may be an illusion born of familiarity. Carbon-based life dominates Earth because carbon is abundant, versatile, and stable within the planet's particular conditions. It forms long chains, complex rings, and reactive bonds that allow information to be stored and copied. But carbon is not the only element capable of complexity. Nor is water the only possible solvent for biochemical reactions. These alternatives are not inventions of speculation. They appear cautiously and repeatedly in real scientific literature as possibilities constrained by known chemistry and physics. The discomfort arises when one realizes how narrow Earth's biochemistry truly is. All known life here shares a common ancestry. Every organism, from bacteria to human, descends from a single lineage that happened to succeed. This unity is remarkable, but it also limits imagination. We do not know whether Earth's chemistry was optimal, only that it worked once and then filled the planet. On other worlds, conditions may favor different molecular strategies: lower temperatures, higher pressures, alternative solvents. In such environments, chemistry might explore pathways Earth never needed. Silicon, for instance, is often mentioned not because it is a fantasy replacement for carbon, but because it shares key bonding properties. Under the right conditions, silicon-based frameworks could form stable, information-carrying structures. Not here, but elsewhere. Even within carbon chemistry, variation abounds. Life on Earth relies heavily on oxygen, yet oxygen is highly reactive and potentially destructive. Its presence shaped Earth's evolutionary trajectory dramatically, driving extinctions as well as complexity. On planets where oxygen never became dominant, or where alternative electron acceptors prevailed, life might follow slower, steadier biochemical pathways. Energy would be extracted more gently, mutation rates might be lower. Stability would once again replace urgency. Water, too, may not be universal. In colder environments, liquids like ammonia or methane can act as solvents, enabling chemical reactions at temperatures far below Earth's norms. On such worlds, reaction rates would be slower, but not non-existent. Life would not rush. Metabolism would unfold patiently, unconcerned with the rapid cycles that dominate Earth's biosphere. This slowness is unsettling because it challenges an implicit assumption that life must operate on timescales humans recognize. Earth's biology feels active, busy, competitive, but these traits may reflect environmental pressure rather than necessity. On worlds where chemistry proceeds calmly and consistently, life may be subtle, nearly invisible by earthly standards. Growth would be measured in centuries. Thought, if it arises, might unfold across generations rather than moments. There is also the question of information itself. DNA is an elegant solution, but not the only conceivable one. Other molecular systems could store and replicate information with equal fidelity under different conditions. Some might be more resistant to radiation, others more stable across temperature ranges. Earth's solution survived because Earth demanded survival. Other worlds may not impose the same tests. When scientists simulate alternative biochemistries, they do so cautiously, constrained by known chemical laws. These are not arbitrary inventions. They emerge from the same periodic table, the same quantum rules. The universe does not change its laws from planet to planet. It simply explores different regions of possibility space. Earth occupies one such region. It is not the center. This realization dissolves another comforting narrative, that intelligence elsewhere would resemble us closely enough to be immediately recognizable. If life's chemistry diverges significantly, then its expressions of intelligence may also diverge. Communication might not rely on sound or light as we know it. Perception might not privilege the same senses. Even the concept of an individual organism could blur, replaced by distributed systems or collective awareness. Earth's intelligence emerged from a biosphere shaped by scarcity and competition. Resources fluctuated. Extinctions reset progress. Under these conditions, cognition favored rapid response, pattern recognition, and predictive control. On worlds where chemistry is stable and resources are abundant, cognition might favor integration over prediction, understanding over reaction, memory over speed. This possibility unsettles the search for life itself. Many detection strategies assume Earth-like chemistry, oxygen signatures, water vapor, familiar gases. But worlds that are truly better for life may not advertise themselves in familiar ways. Their biospheres may be chemically quiet, leaving few dramatic markers in their atmospheres. From a distance, they might appear sterile, even though they are anything but. There is a subtle irony here. The very features that make Earth life detectable, reactive gases, rapid cycles, atmospheric disequilibrium, may be signs of stress rather than health. A stable biosphere might leave a gentler fingerprint, one that current instruments struggle to notice. The calmest worlds could be the hardest to find. This reframes the question of uniqueness. Earth's life is not unique because it is complex. It may be unique because it is noisy, chemically active, energetically imbalanced. Other biospheres might exist in quieter equilibrium, exchanging matter and energy so smoothly that they barely disturb their surroundings. From a philosophical perspective, this challenges anthropocentrism at a deeper level. It suggests that intelligence need not look like urgency, expansion, or technological acceleration. Those traits may reflect Earth's particular chemical and environmental pressures. Other forms of intelligence may emerge without ever needing to reshape their planets or announce their presence. If chemistry sets the tempo of life, then different chemistries set different tempos of awareness. Earth's awareness feels fast because Earth's chemistry is fast, but speed is not depth. Rapid thought is not necessarily profound thought. Slower biochemical systems may support forms of understanding inaccessible to hurried minds. The universe does not appear to favor one chemical pathway over all others. It allows many. Earth's path is simply the one we inherited. The idea that it represents the pinnacle of biological possibility becomes increasingly fragile as these alternatives are considered. Somewhere, perhaps beneath an alien sky and within a solvent that never freezes or boils violently, chemistry may have assembled life that experiences existence as a slow unfolding rather than a constant reaction. Intelligence there may not ask how to survive, but how to persist meaningfully within a stable whole. And the question drifts forward, unresolved and quietly disorienting. If consciousness can arise from chemistries that do not mirror our own, then how many forms of awareness might already exist in the universe, present, patient, and utterly unrecognizable to a species whose understanding of life was shaped by urgency, volatility, and speed? Time is often treated as a neutral backdrop, a silent axis along which events unfold. Seconds pass, years accumulate, epochs dissolve into one another. But for life, time is not neutral at all. It is the medium through which complexity either survives long enough to deepen or is interrupted before it can stabilize. And on Earth, time has never flowed smoothly. The history of life here is marked by pauses and ruptures. Long stretches of gradual change are repeatedly punctured by sudden endings. Mass extinctions arrive without regard for progress, erasing lineages that took tens of millions of years to assemble. Intelligence, culture, memory, none of these are immune. Earth's timeline resembles a manuscript constantly overwritten, its margins crowded with lost possibilities. From an evolutionary perspective, these interruptions are not just dramatic events. They are structural constraints. Each reset compresses the future, forcing life to rebuild from simpler forms. Evolution does not resume where it left off. It detours, improvises, compromises. Complexity is not guaranteed to return in the same way, or at all. This is where the idea of better worlds quietly resurfaces. Not worlds with faster evolution, but worlds with fewer interruptions. Worlds where time is allowed to do what it does best: accumulate structure. On planets spared frequent catastrophe, evolution could proceed uninterrupted for billions of years. Intelligence there would not be a late arrival. It might be an early outcome that simply had time to mature. Earth's intelligence appeared astonishingly late in the planet's history. For most of its existence, life remained simple. This delay is often attributed to chance, but chance alone does not explain repeated setbacks. Each global catastrophe postponed complexity. Each extinction erased experiments that might have led elsewhere. Intelligence here is not the product of uninterrupted development. It is the survivor of repeated erasure. Consider what uninterrupted time would allow. Biological systems refine through iteration. Neural architectures deepen through continuity. Culture stabilizes through transmission. None of these thrive under frequent collapse. A civilization that must rebuild from ruins every few thousand years never accumulates the depth of understanding possible under stable conditions. Knowledge fragments. Memory thins. On planets where mass extinctions are rare or mild, the arc of development would look very different. Life would not need to constantly reassert its foothold. It could specialize without fear that specialization would become fatal. Ecosystems would layer upon ecosystems, each generation inheriting a richer foundation than the last. This difference is subtle but transformative. Earth's biosphere is resilient because it had to be. Resilience became a defining trait, but resilience is not refinement. It prioritizes survival over coherence. On calmer worlds, life might prioritize integration, systems fitting together so well that disruption becomes unlikely in the first place. Time also shapes consciousness. Awareness is not merely a biological accident, it is an accumulation of pattern recognition, memory, and prediction. These faculties deepen when they are not repeatedly reset. A mind that inherits uninterrupted cultural memory for millions of years would not resemble one that emerged only yesterday on a cosmic clock. Perspective would stretch. Urgency would dissolve. Earth's civilizations, by contrast, live under the shadow of fragility. Climate instability, geological threats, cosmic hazards. These are not abstractions here. They are recurring features. As a result, human culture developed with a strong emphasis on immediacy. Act now. Secure resources. Prepare for loss. These instincts feel universal, but they may simply be local adaptations to an unstable timeline. On worlds with deep temporal continuity, planning might extend across epochs rather than decades. Decisions would not be driven by fear of imminent collapse. Progress would not need to accelerate constantly to outrun extinction. The idea of rushing toward the future might feel unnecessary, even irrational. Earth's scientific imagination often assumes that faster evolution leads to greater intelligence. But speed is not depth. Rapid change can produce novelty, but it can also prevent consolidation. Slower evolution under stable conditions might allow intelligence to integrate knowledge more fully, producing forms of understanding that are not only advanced, but coherent across immense spans of time. This possibility complicates how intelligence elsewhere is imagined. If it arises early and persists long, it may no longer resemble something emergent. It may feel embedded, woven into planetary systems rather than standing apart from them. Technology might not explode outward. It might dissolve inward, becoming indistinguishable from ecology. The difficulty in detecting such intelligence is obvious. Earth's search strategies often look for rapid change. Industrial signatures, artificial emissions, atmospheric disturbances. But a civilization that developed slowly and sustainably might leave few detectable traces. Its footprint would be light, its presence quiet. From afar, it could be mistaken for absence. This leads to a paradox. The most advanced forms of life may be the least visible, not because they hide, but because they never needed to announce themselves. Their planets would not bear scars of exploitation or rapid transformation. Their atmospheres would remain balanced. Their energy use would blend seamlessly into natural cycles. Earth's story feels dramatic because it has been interrupted so often. Drama is a symptom of instability. Other worlds may tell quieter stories, stories without sharp beginnings or endings, without clear moments of collapse. To minds shaped by catastrophe, such stories may feel empty. But emptiness may be a misreading of calm. There is also a psychological consequence to long, uninterrupted time. When collapse is not expected, fear loses its grip. Motivation shifts. Instead of asking how to survive, intelligence asks how to understand. Instead of racing towards solutions, It explores questions slowly, thoroughly, without pressure to conclude. Earth's sciences emerged under urgency. Knowledge here often advances in response to crisis. Other intelligences may pursue knowledge for its own sake, unconstrained by deadlines imposed by planetary instability. Their understanding of reality might be broader, less fragmented, less reactive. The universe, viewed this way, does not favor brilliance born of crisis. It permits it, but it also permits wisdom born of patience. Earth has sampled the former. The latter may be unfolding elsewhere, unnoticed, and so the thought lingers, unresolved and quietly profound. If uninterrupted time is the true catalyst for deep intelligence, then how many worlds may already host minds shaped not by survival through catastrophe, but by continuity so long and gentle that urgency itself never became a defining feature of thought? Light feels like certainty. It arrives each morning without question, fills space effortlessly, and defines what can be seen. On Earth, vision became the dominant sense, shaping how intelligence understands reality. What is illuminated feels real. What lies beyond the visible spectrum feels abstract. Yet this confidence rests on a narrow coincidence. The light that reaches Earth's surface occupies only a thin slice of what the universe actually emits. The sun radiates across a broad range of wavelengths, but Earth's atmosphere filters most of them out. What remains is a window tuned almost perfectly to human vision. This coincidence has long been celebrated as evidence of fine balance, as though the universe adjusted itself to be seen. But there is another interpretation. That perception adapted to what happened to be available, not the other way around. Other stars shine differently. Some emit far more infrared light. Others lean toward ultraviolet. Around these stars, the dominant form of illumination would feel alien to Earth-based eyes. Yet alien does not mean hostile. Life, if present, would adapt its biochemistry and sensory systems accordingly. Vision might not be based on reflected light at all, but on thermal gradients, electromagnetic fields, or chemical flux. On Earth, reliance on visible light shaped intelligence in subtle ways. It encouraged spatial awareness, pattern recognition, and a focus on surfaces. Much of human cognition is oriented outward, scanning the environment for change. This makes sense on a planet where visibility fluctuates, where night falls suddenly, where shadows conceal danger. Light here is intermittent, precious, something to be secured. On planets orbiting cooler stars, illumination may be constant but faint. Instead of sharp day-night cycles, there might be perpetual twilight. Instead of brilliant contrast, gradual gradients. In such environments, the urgency associated with light might never arise. Awareness would not be driven by sudden loss of visibility. Perception would unfold slowly, attuned to subtle shifts rather than abrupt signals. This difference matters because perception shapes cognition. A mind that evolves under gentle, continuous illumination may not prioritize reaction speed. It may favor integration over immediacy. Thought would not be organized around moments of sudden revelation, but around ongoing processes. Knowledge would feel less like discovery and more like recognition. Earth's atmosphere further complicates the story. It scatters light, creates color, and limits resolution. Blue skies and red sunsets are aesthetic byproducts of physics, not necessities. On other worlds, skies might appear dark even at noon, or glow softly without shadows. Life there would not associate brightness with safety or darkness with threat. These associations are learned, not universal. Astronomical observations reinforce this diversity. Telescopes reveal planets orbiting stars that emit energy predominantly outside Earth's visible range. Around such stars, photosynthesis, if it occurs, would rely on different wavelengths. Pigments would not be green. They would be tuned to what is abundant, not what is familiar. Life would literally see a different universe. This realization destabilizes a common assumption that intelligence requires environments similar to our own. If perception adapts to available information rather than dictating it, then radically different sensory worlds could support equally rich awareness. Intelligence does not need clarity, it needs consistency. Earth's clarity is deceptive. The visible world feels comprehensive because it is what the brain evolved to process. Yet vast information passes through us unnoticed. Radio waves, infrared radiation, neutrinos, all flow through the planet constantly. Life here learned to ignore them because they were not useful for survival. On other worlds, different signals may dominate awareness entirely. There is also a philosophical tension here. Human thought often equates truth with visibility. Seeing is believing. What cannot be seen feels speculative. But if other intelligences evolved without privileging visible light, their concept of evidence might be fundamentally different. Truth might be sensed as equilibrium rather than observation, as continuity rather than contrast. This difference would shape how such beings understand the universe. Earth's science advanced through observation, measurement, and visual instrumentation. Other intelligences might prioritize internal consistency, energetic balance, or long-term pattern stability. Their sciences would not be inferior, just oriented toward different dimensions of reality. Detection becomes a challenge under this perspective. Earth's search for life often relies on visual or electromagnetic signatures that align with human expectations. Bright signals, sharp contrasts, artificial illumination. But a civilization that evolved under dim, steady light might never produce such signatures. Its technologies, if they exist, would blend into the background rather than stand out against it. Observatories like the Hubble Space Telescope have revealed breathtaking diversity in stellar light, but interpretation remains filtered through Earth-based perception. We look for familiar colors, familiar patterns. We may be overlooking worlds where life thrives quietly, illuminated by spectra we barely register. Earth's relationship with light also shaped its myths and metaphors. Light represents knowledge, goodness, revelation. Darkness represents ignorance, danger, absence. These symbolic structures are deeply embedded in culture and language. On planets where illumination is constant, or where darkness is never threatening, such metaphors might never arise. Knowledge would not be framed as illumination. Ignorance would not be darkness. This symbolic difference hints at deeper cognitive divergence. Earth's intelligence learned to associate understanding with sudden clarity. Breakthroughs, moments of insight. On worlds where perception is continuous and subtle, understanding may feel gradual, without dramatic turning points. Wisdom would not arrive in flashes. It would accumulate quietly. Light also influences time perception. Day-night cycles regulate circadian rhythms. Seasons mark the passage of years. On planets with minimal variation in illumination, time might not be experienced as a sequence of repeating units. Instead, it would feel continuous, unsegmented. Memory would not anchor itself to cycles, but to slow change. Such differences reshape the concept of advancement. Earth's civilizations often measure progress by increasing brightness. Cities glowing at night, signals reaching farther into space. but brightness is a choice shaped by darkness. Where darkness does not threaten, illumination need not dominate. Advancement there might be measured by harmony rather than reach. The universe offers no single way to see. It offers spectra, gradients, flows. Earth sampled one narrow band and built its intelligence around it. Other worlds may sample others. Their awareness may feel foreign, not because it is lesser, but because it is tuned to aspects of reality we overlook. If planets exist where light never dazzles and darkness never alarms, then intelligence there would not equate visibility with truth. It would not seek certainty through illumination. It would seek understanding through persistence, through long observation of slow patterns that rarely demand attention here. And the question remains, unresolved and quietly unsettling. If perception itself adapts to what a world provides rather than revealing what is fundamentally real, then how many forms of intelligence may already exist, perceiving dimensions of the universe that remain invisible to us? Not because they are hidden, but because our eyes were never shaped to see them at all. At some point in the search for better worlds, the question turns inward, not toward planets or stars, but toward the observer who is asking, why does Earth feel so precisely tuned for life? Why do its conditions appear balanced just well enough to allow awareness to emerge and ask about balance at all? This feeling of precision has often been mistaken for evidence of design. Yet there is another interpretation, quieter and more unsettling, one that dissolves certainty rather than reinforcing it. The anthropic perspective suggests that the universe does not need to be ideal everywhere, only somewhere. Observers can arise only in regions where conditions allow them to arise. This sounds almost trivial, but its implications are profound. It means that Earth's apparent suitability does not require explanation in terms of optimization. It may simply be the minimum threshold that allowed observation to occur. Not the best place for life, just a place where life happened not to fail. This reframes the sense of cosmic hospitality. Earth may not be special because it is finely tuned. It may be special only because it is inhabited. The distinction is subtle but destabilizing. If countless worlds exist where conditions were nearly suitable but fell short, no one would be there to notice them. Only the survivors ask questions. From this angle, Earth's fragility takes on new meaning. The narrow margins that allowed life to persist are not signs of perfection. They are signs of contingency. The planet does not appear to have been optimized for comfort or longevity. It appears to have barely met the criteria required for continuity. And continuity, once achieved, tends to explain itself. This idea unsettles because it removes humanity from the center of explanation. It suggests that Earth's life-supporting qualities were not selected for life. Life selected them, after the fact, by existing there. The universe did not aim. It allowed. And allowance is not intention. When astronomers speak of planets better for life, they often do so cautiously, aware of this bias. Better does not mean destined. It means statistically more forgiving. Worlds with thicker atmospheres, longer-lived stars, and stable climates offer wider margins. Life there would not be balanced on a knife's edge. It would have room to fail and recover. Room, Earth rarely enjoyed. The discomfort deepens when this perspective is applied to intelligence itself. Human consciousness often interprets its own existence as improbable, therefore meaningful. But improbability does not imply purpose. Rare outcomes occur constantly in large systems. In a universe with hundreds of billions of galaxies, even highly unlikely configurations will appear, not because they were intended, but because there were enough chances. This shifts the question from why are we here to how many ways could this have happened? Earth represents one way, not necessarily the best, not necessarily repeatable, just one outcome among many. Other worlds may host life that never questions its own improbability because it never needed to survive so close to failure. The anthropic lens also explains why Earth's conditions feel finely balanced. Any significant deviation would have prevented observers from forming. But this does not mean deviations are rare. It means observers do not experience them. This creates a selection effect so powerful that it can be mistaken for design. Better worlds challenge this illusion. They suggest that Earth may lie near the lower bound of habitability rather than near the peak. Life here survived despite repeated catastrophes, not because those catastrophes were necessary. Intelligence emerged late, fragile, and easily threatened. On worlds with broader margins, intelligence might emerge earlier and persist longer, never experiencing its own existence as improbable. There is a philosophical tension here that resists resolution. If observers can only arise in suitable conditions, then suitability becomes invisible. Every observer feels as though their world is uniquely balanced because imbalance leaves no witness. This does not trivialize existence, it contextualizes it. The search for life beyond Earth is shaped by this realization. Programs associated with organizations like SETI Institute attempt to detect signals that resemble our own. Narrowband transmissions, technological artifacts, energetic emissions. But these searches assume that intelligence elsewhere would experience the same urgency to signal, to expand, to announce itself. That assumption may reflect Earth's precarious history rather than a universal impulse. If intelligence arises on worlds where extinction is rare and continuity is long, it may not feel compelled to reach outward. It may not perceive the universe as hostile or empty. Exploration might be internal rather than external. Understanding might deepen locally rather than spread aggressively. From an anthropic standpoint, Earth's restlessness becomes an explanatory factor rather than a virtue. Instability encourages exploration, communication, and technological acceleration. Intelligence here learned to look outward because its environment demanded solutions beyond immediate surroundings. Other intelligences may never face that demand. This perspective also reshapes the idea of cosmic loneliness. Earth's silence may not indicate absence, it may indicate mismatch. We listen for echoes of our own urgency, our own noise. Quieter forms of intelligence would leave no such echoes. Their existence would not register against our expectations. The anthropic principle does not answer whether better worlds exist. It explains why. If they do, we might not be there. We are here because here was survivable, not because here was optimal. The universe does not guarantee that observers arise in the most favorable conditions, only that they arise somewhere favorable enough. This realization carries an unexpected humility. It suggests that Earth's struggles were not trials designed to forge intelligence. They were accidents endured. Intelligence here adapted to scarcity, volatility, and threat. Those adaptations shaped culture, psychology, and philosophy. Other adaptations may be possible under gentler conditions. From a broader cosmic view, intelligence may be a spectrum rather than a peak. Earth occupies one region of that spectrum, shaped by narrow margins and repeated resets. Other regions may exist where intelligence matured slowly, quietly, without ever needing to ask whether it belonged. The anthropic lens dissolves the need for cosmic favoritism. It does not diminish meaning, but it relocates it. Meaning arises not from being chosen, but from being aware, from recognizing contingency and still asking questions. Earth's awareness feels sharp because it was forged under pressure. Other awarenesses may feel broad because they were forged under continuity. Neither is superior. They are responses to different constraints. As the idea of better world settles in, the question shifts again. Not toward envy or aspiration, but toward recognition. If Earth is not the ideal, but merely the sufficient, then the universe may host many forms of life that never experience themselves as improbable at all. And the thought remains, unresolved and quietly transformative. If our sense of specialness emerges not from optimization, but from survival bias, then how many intelligences may already exist who never asked whether their world was better? Because for them, existence never felt precarious enough to demand the question in the first place. When the idea of better worlds is followed to its farthest edge, it begins to blur into a different question altogether. One that no longer asks which planets are more hospitable, but why the universe permits hospitality at all. The numbers behind reality are strangely permissive. Physical constants sit within narrow ranges that allow matter to form, stars to burn, chemistry to persist. Shift them slightly, and complexity dissolves. This apparent delicacy has unsettled physicists for decades, not because it proves intention, but because it resists simple explanation. One response to this tension is the notion of fine-tuning. The universe appears calibrated, as if certain values were set just right. But calibration implies a hand, and physics hesitates at hands it cannot measure. An alternative response avoids intention entirely. It suggests multiplicity, not one universe delicately adjusted, but many universes with different parameters, most barren, a few permissive. In such a landscape, Earth does not need to be chosen. It only needs to be possible. This idea appears in multiverse theories, which arise naturally from inflationary cosmology and quantum mechanics. They are not invented to explain life. They emerge from attempts to reconcile known equations. In these frameworks, universes differ the way planets differ, by initial conditions, by constants, by outcomes. Most combinations lead nowhere. Some lead to stars. Fewer still lead to life. If this picture is correct, then the existence of worlds better than Earth becomes not just plausible, but expected. In a sufficiently large ensemble, there will be planets that sit deeper within the habitable envelope, wider margins, longer timelines, gentler dynamics. Earth would not be exceptional. It would be adequate. The discomfort deepens when this logic is extended to consciousness. If universes vary, and planets vary within them, then minds arise where conditions allow minds to arise. There is no guarantee that our kind of mind is the most likely outcome. It is simply one that occurred. Other minds may arise under conditions that feel alien, not because they are improbable, but because we are unaccustomed to the range. Simulation hypotheses take this logic one step further, not by asserting that reality is artificial, but by asking whether complex systems tend to generate nested realities as a byproduct of intelligence. This idea appears in philosophical and computational discussions, not as proof, but as a boundary case. If advanced intelligences can simulate environments in detail, then simulated worlds may outnumber original ones. In that scenario, apparent fine-tuning would not require cosmic intent, only design within design. These ideas are not claims. They are pressures placed on explanation. They exist because simpler answers fail to close the gap between permissive physics and contingent existence. Whether through multiverse or simulation, The question remains the same. Why do conditions allow not just life, but life with room to spare elsewhere? Better worlds fit uncomfortably well into these frameworks. If reality explores possibilities freely, then Earth's constraints are not optimal settings, they are local ones. Other configurations may be more stable simply because nothing forced them to be otherwise. The universe does not optimize globally, it samples. From this perspective, Earth feels provisional, a version that worked. Not the best version, not the worst. The idea that consciousness might arise in calmer settings elsewhere becomes less threatening and more inevitable. In a wide enough possibility space, patience will eventually produce awareness without urgency. This shifts how meaning is located. If existence is one outcome among many, then significance does not come from being rare. It comes from being realized. A mind that emerges under forgiving conditions may never feel astonished by its own presence. It would not ask why the universe allowed it. Allowance would feel normal. Human astonishment may reflect Earth's narrow margins rather than a universal property of consciousness. Awareness here arose close to failure, under repeated threat. That proximity sharpened reflection. It produced philosophy. It produced doubt. Other awarenesses may arise far from failure, where existence does not demand explanation. Physics itself hints at this unevenness. The same laws produce black holes and empty voids, stable stars and violent explosions. There is no preference expressed. Reality allows extremes and balances alike. Better worlds would simply occupy quieter regions of this spectrum. Institutions that probe fundamental physics, such as CERN, search for unifying principles that reduce contingency. Yet each unification often reveals deeper parameters rather than eliminating them. The closer physics comes to foundations, the more it encounters possibility rather than necessity. This is where fine-tuning ceases to be comforting. It does not imply care, it implies permissiveness. The universe allows certain arrangements, and within those arrangements, life occasionally appears. Earth is one such appearance. Others may be more stable, not because they were favored, but because nothing disrupted them. Better worlds, in this sense, are not aspirational destinations. They are reminders that Earth's struggles are not universal. That intelligence need not be forged under pressure. That awareness may arise without ever experiencing itself as precarious. If simulated or multiversal realities exist, then the concept of best dissolves further. There would be no global optimum, only local equilibria. Worlds where parameters drift into gentler alignments would not be superior. They would be quieter, less dramatic, more enduring. This endurance changes how intelligence might relate to reality. Without the need to justify existence against improbability, thought would not circle around origins. It would explore structures, patterns, long arcs. Meaning would be discovered in continuity rather than exception. Earth's narratives are filled with beginnings and endings, creation, myths, apocalypses, final judgments. These reflect a world where disruption is common. On worlds that rarely disrupt, stories may not center on origins at all. They may center on balance, on maintenance, on slow transformation that never requires reset. The fine-tuning debate often ends in stalemate, not because answers are forbidden, but because the questions exceed verification. Yet better worlds give the debate texture. They suggest that Earth's apparent precision may be a lower bound, not a target. A threshold crossed, not a peak reached. In that light, the universe feels less like a riddle posed to humanity and more like a vast field of variation where humanity happened to awaken in one corner. Other corners may be waking now, or may have awakened long ago, under conditions that never inspired existential alarm. The unsettling calm of this view lies in its indifference. Reality does not need to explain itself to produce awareness. It only needs to permit it somewhere, sometime. Earth met that condition narrowly. Others may meet it generously. And so the thought remains suspended, neither proven nor dismissed. If the universe naturally produces many realities, with many degrees of hospitality, then Earth's struggles tell us less about cosmic intention and more about local circumstance. And somewhere beyond our horizon, awareness may already be unfolding in worlds so forgiving that the question of fine-tuning never felt urgent enough to ask. The search for life beyond Earth is often imagined as a widening gaze, telescopes peering farther into space, instruments growing more sensitive. But there is another dimension to this search that receives less attention: the way expectation shapes perception. What we look for determines what we notice, and what we fail to imagine quietly disappears from the data, not because it is absent, but because it does not fit the pattern we prepared ourselves to see. Most methods used to identify potentially life-bearing planets are built around Earth as a reference. Atmospheric oxygen, liquid water signatures, temperature ranges familiar to terrestrial biology. These markers make sense. They are grounded in experience, but they also encode an assumption that life elsewhere will announce itself in ways that resemble how life announced itself here. The possibility that better worlds might leave subtler traces introduces a troubling asymmetry. The most life-friendly planets may be the least obvious. Earth's biosphere is chemically noisy. Its atmosphere is far from equilibrium. Oxygen and methane coexist in ways that demand constant replenishment. From a distance, this imbalance is detectable. It stands out. It signals activity. Yet imbalance is not necessarily a sign of health. It is a sign of flux. A stable biosphere, tightly integrated with its planet, might approach equilibrium instead. It would recycle matter so efficiently that atmospheric signatures would appear muted, even lifeless. This creates a paradox. Worlds that are just stable enough for life to persist, but not stable enough to settle, may be the easiest to find. Worlds that are deeply stable, where life has integrated seamlessly into planetary systems, may leave almost no detectable fingerprint. From afar, they could look inert, their calm mistaken for emptiness. Observational bias deepens this problem. Telescopes are tuned to notice change, transits, spectral shifts, fluctuations. Dramatic systems reveal themselves readily. Quiet systems do not. A planet whose climate, atmosphere, and biosphere have remained within narrow bounds for billions of years offers little variation to measure. Its silence is not a lack of life. It is a lack of disturbance. Earth's own detectability may be a consequence of its instability. Oxygen levels rose sharply in the past. Methane surged and collapsed. Ice ages reshaped reflectivity. Each of these events left signatures that, if observed from afar, would appear as signs of activity. A calmer Earth might have been harder to notice, even while supporting a richer, more continuous biosphere. This perspective reshapes how habitable zones are understood. These zones are often drawn as neat rings around stars based on where liquid water could exist. But habitability is not a binary condition. It is a spectrum of tolerance. Some worlds sit near the edges of this spectrum, constantly adjusting, constantly visible. Others sit deep within it, rarely deviating, rarely announcing themselves. Detection strategies favor the edges. They favor contrast. This bias may explain why many of the planets discovered so far appear extreme. Hot Jupiters, superdense worlds, planets with wild atmospheres. Calm, Earth-sized planets in stable orbits around quiet stars are harder to detect. Their signals are subtle, their transits shallow, their spectra restrained. Space missions have begun to confront this limitation. Surveys conducted by the Gaia Space Observatory, for example, map stellar motions with exquisite precision, revealing planets indirectly through gravitational effects rather than atmospheric drama. These methods hint at a population of worlds that do not announce themselves loudly. Worlds that simply exist, moving their stars gently, steadily, without spectacle. There is also a cultural bias embedded in the search. Human curiosity gravitates toward extremes. We ask whether planets are hotter than Earth, colder than Earth, larger, denser, more violent. These comparisons feel meaningful because Earth feels central. But better worlds may not be more extreme. They may be more moderate. Moderation rarely draws attention. This bias extends to how intelligence is imagined. Many searches focus on technological signatures, radio emissions, lasers, industrial pollutants. These are expressions of rapid technological expansion, of societies that reshape their environment quickly, but such behavior may be a response to scarcity and instability. On worlds where resources are abundant and environments forgiving, intelligence may never feel compelled to broadcast or industrialize at scale. A civilization that develops slowly, sustainably, and locally may leave no detectable technological imprint. Its energy use would blend into planetary cycles. Its materials would be recycled. Its signals would be internal. From Earth's perspective, such a civilization would be invisible, not because it is primitive, but because it is integrated. The more this possibility is considered, the more silence takes on ambiguity. The absence of evidence does not necessarily indicate absence of life. It may indicate a mismatch between expectation and reality. Earth's own history shows how easy it is to overlook life when it does not conform to familiar forms. Microbial ecosystems remained undiscovered for most of human history, not because they were hidden, but because they were not anticipated. Better worlds may host biospheres and intelligences that are similarly overlooked on a cosmic scale. Their quietness would not be a failure to evolve. It would be an outcome of stability. When nothing demands attention, nothing announces itself. There is a subtle irony in this. Humanity often assumes that advanced intelligence will be conspicuous, bright, energetic, expansive. Yet these traits may correlate with environmental pressure rather than advancement. Earth's intelligence grew under threat. It learned to act quickly, to externalize tools, to modify surroundings. Other intelligences may grow under trust, learning to refine internal coherence rather than external reach. This challenges the emotional narrative of discovery. The expectation of dramatic contact, of unmistakable signals, may be unrealistic. Recognition, if it ever occurs, may be ambiguous, indirect, and quiet. It may arrive not as a message, but as a realization that certain worlds are too balanced to be empty. As detection techniques improve, the temptation will be to interpret every anomaly as significance. But anomalies favor disturbance. Calm requires different tools, different patience. It requires accepting that the most hospitable worlds may not reveal themselves through spectacle. The universe does not advertise its successes, it allows them to persist. Earth's life persists loudly because it has been repeatedly disturbed. Other life may persist silently because it has not. This shifts the emotional center of the search. Instead of waiting for proof that mirrors our own history, the search becomes an exercise in humility. learning to notice what does not clamor for attention, learning to interpret equilibrium as potential rather than absence. If better worlds exist, they may not be found where the universe looks most dramatic. They may orbit quietly under stars that rarely flare, with atmospheres that barely change, biospheres that recycle so efficiently they leave no excess. Their existence would be inferred not from noise, but from balance. The thought lingers, unresolved and quietly challenging. If the most life-friendly worlds are the least detectable, then how many inhabited planets might already surround us? Unseen, not because they are rare, but because they are too stable, too integrated, too complete to betray themselves to a search shaped by Earth's own restlessness? By this point in the journey, the idea of a better world begins to feel unstable. Better for what, exactly? Better for the emergence of life, for its persistence, for the flowering of intelligence, or for something more elusive, meaning, understanding, coherence? Each criterion reshapes the answer. What appears ideal under one lens becomes questionable under another. The concept resists fixation, slipping away each time it seems within reach. Earth's conditions fostered a particular kind of intelligence, alert, adaptive, restless. Life here learned to respond quickly, to anticipate disruption, to extract value before circumstances shifted again. These traits are often celebrated as strengths, but they are also symptoms. They reflect a world where continuity could never be assumed. Intelligence became a strategy for managing instability. On worlds where instability is rare, intelligence might not serve the same function. It would not be needed to outpace catastrophe or dominate resources before loss. Instead, it might arise as an extension of equilibrium, an awareness embedded within long-standing systems rather than positioned against them. Such intelligence would not feel like a breakthrough. It would feel like maturation. This reframing dissolves a hidden hierarchy. Earth's intelligence is not necessarily more advanced because it is more visible or energetic. It is simply adapted to a harsher rhythm. Other intelligences may be quieter, not because they are less capable, but because they never needed to be loud. The word better carries a subtle anthropocentric bias. It assumes that the goals of life are aligned with human intuitions: expansion, complexity, speed, novelty. But life's only universal requirement is persistence. Everything else is contextual. A world that supports uninterrupted persistence may be better for life in a sense that has nothing to do with spectacle or progress. Earth's narrative emphasizes turning points, origins, revolutions, collapses. These punctuations give history a shape. On worlds where change is slow and continuity dominates, history might not feel segmented at all. There would be no dramatic arcs, no sharp thresholds. The past would blend seamlessly into the present. Memory would be deep but diffuse. From such a perspective, Earth might appear chaotic. Its rapid transitions, frequent resets, and bursts of innovation could seem inefficient or even crude. Why rebuild so often? Why allow so much loss? These questions only arise when continuity is known. Earth never had that luxury. The challenge is that human language struggles to describe value without comparison. Better implies worse. Ideal implies flawed. But the universe does not appear to operate on such rankings. It produces conditions. Life responds. Intelligence emerges when it can. Some environments favor speed, others favor stability. None are universally superior. This ambiguity becomes especially apparent when considering meaning. On Earth, meaning often arises from contrast, from struggle, from overcoming limits, from surviving against odds. But meaning need not be forged in adversity. On worlds where survival is not constantly threatened, meaning might emerge from balance, from integration, from understanding relationships that persist across deep time. Such meaning would not be dramatic. It would not demand expression through monuments or conquest. It would be lived rather than declared. Earth's civilizations externalized meaning because they feared loss. Other civilizations may internalize meaning because continuity feels assured. This does not imply moral superiority. It implies difference shaped by environment. Ethics, aesthetics, and purpose all arise from local constraints. A species evolved under constant threat will value resilience and foresight. A species evolved under stability may value harmony and patience. Neither set of values is universal. The idea that Earth might not be the best possible cradle for life unsettles because it destabilizes identity. Humanity often defines itself through uniqueness, through occupying a special place in a finely balanced cosmos. Removing that specialness feels like diminishment, but it may instead be a redistribution of significance. Meaning does not vanish when it is shared. It changes form. If better worlds exist, they do not diminish Earth. They contextualize it. They suggest that Earth is one expression of a broader pattern rather than its culmination. This perspective invites humility without erasing wonder. The universe becomes not less meaningful, but less centered on any single outcome. There is also a quiet relief in this view. If Earth's difficulties are not necessary for intelligence, then suffering is not a prerequisite for awareness. Consciousness need not be forged through loss. It can arise through patience, through long equilibrium, through systems that rarely break. This does not negate Earth's history. It reframes it as one path among many. A path shaped by narrow margins and repeated disruption. A path that produced a certain kind of mind, one that asks questions urgently, seeks solutions quickly, and looks outward for answers. Other minds may ask fewer questions, not because they know less, but because their worlds do not demand constant interrogation. Their understanding may be tacit rather than explicit, woven into practice rather than articulated through theory. Knowledge would not be accumulated to prevent collapse. It would be refined to maintain balance. The unsettling implication is that Earth's intelligence may be unusually preoccupied with origins, endings, and explanations precisely because it arose where none of these could be taken for granted. On worlds where continuity is assumed, curiosity may turn elsewhere, toward patterns rather than beginnings, toward maintenance rather than conquest. This challenges the expectation of encounter. If humanity ever intersects with other forms of intelligence, the meeting may not feel like recognition. The values, motivations, and even the questions themselves may not align. What feels central here may feel peripheral elsewhere. The universe does not promise symmetry. It allows divergence. Better worlds may exist not as upgraded versions of Earth, but as different answers to the same permissive laws. Comparing them requires abandoning the idea that there is a single scale of success. As this realization settles, the journey circles back to Earth, not as a standard, but as a participant. A world that supported life under pressure. A world that produced intelligence eager to understand because understanding felt urgent. That urgency shaped science, philosophy, and the search itself. Better worlds may not search at all. They may not feel incomplete. Their awareness may be content to remain local, deepening understanding without expansion. From Earth's perspective, this contentment can be mistaken for absence. And so the question remains open. neither comforting nor despairing. If better is not a universal category, but a local adaptation, then what does it truly mean to seek life beyond Earth? And are we prepared to recognize intelligence that never needed to define itself against a fragile world the way we did? As the journey draws closer to its quiet edge, the universe begins to feel less like a question demanding an answer and more like a landscape that simply continues. Worlds orbit, stars burn at their own pace, conditions assemble and dissolve without ceremony. Somewhere within this vastness, Earth turns, carrying life that wonders whether it could have been otherwise, and whether elsewhere it already is. The idea that planets more hospitable than Earth may exist does not arrive with triumph or disappointment. It arrives with a subtle shift in orientation. Earth no longer feels like a destination. It feels like a moment, a configuration that happened to hold long enough for awareness to arise and look back at itself. Not the best possible place for life, not the worst, just one that crossed a threshold. Seen this way, Earth's history feels less like a heroic ascent and more like a narrow passage. Life threaded its way through instability, adapting to volatility rather than resting within balance. Intelligence emerged not because conditions were generous, but because they were just permissive enough. Awareness here learned to ask questions urgently, as if time itself were pressing close. Better worlds, if they exist, do not stand in contrast to Earth as rivals. They stand alongside it as alternatives, other ways the universe allows persistence, other rhythms of time, other relationships between life and environment. Their existence would not negate Earth's meaning. It would dissolve the illusion that meaning depends on uniqueness. The universe, viewed without expectation, does not appear to build toward an ideal. It does not refine endlessly toward perfection. It explores. It samples. It allows conditions to arise, persist, and fade. Some combinations produce fleeting sparks. Others sustain long, quiet continuities. None are privileged by the laws that govern them. This perspective carries a quiet humility. It suggests that Earth's dramas, its extinctions, its accelerations, its urgencies, are not cosmic necessities. They are local experiences. Other worlds may never know them. Intelligence elsewhere may never ask how close it came to non-existence because it never stood so near the edge. If such intelligences exist, their understanding of reality would feel different, not sharper or duller, but oriented around endurance rather than survival. Meaning would not need to be wrested from chaos. It would emerge from continuity. Knowledge would not accumulate against the threat of loss. It would unfold naturally within stable systems. Earth's awareness is shaped by interruption. Memory here is fragile. History is punctuated. Progress feels provisional. These qualities made reflection intense. They made philosophy urgent. They made science feel necessary. Other minds, shaped by gentler conditions, may never feel compelled to explain existence in the same way. Existence would not feel surprising enough to justify the question. This is not a diminishment of human inquiry. It is an explanation for its tone. Earth's questions are sharp because Earth's margins were narrow. Curiosity here is driven by contingency, the sense that things could have failed, the fear that they still might. In calmer worlds, curiosity might take a different form. Not an interrogation of origins, but a deepening of relationships. Not a search for ultimate explanations, but an attention to patterns that persist. Understanding would not seek closure. It would seek alignment. The silence encountered when searching the cosmos may reflect this difference. Not absence, but non-participation in the same narrative. Earth listens for echoes of its own urgency, signals of expansion, markers of rapid change. Other intelligences may not generate such echoes because their worlds never demanded haste. If contact ever occurs, it may not arrive as revelation. It may arrive as dissonance. A realization that intelligence does not share a single trajectory. That awareness does not culminate in a recognizable form. That the universe permits many ways of knowing without insisting they converge. As the idea of better worlds settles, the search itself becomes less about comparison and more about context. Earth is no longer the yardstick. It is a data point, a world that taught life to endure rather than rest. A place where intelligence learned to hurry because time felt limited. Elsewhere, time may feel abundant, so abundant that intelligence does not feel the need to measure itself against the cosmos. It would not look outward for confirmation. It would exist comfortably within its own continuity. The unsettling calm of this realization lies in its refusal to flatter. Earth is not the crown of creation. It is not the universe's favored experiment. It is one experiment that happened to work. Others may be working still, quietly, beyond detection, unconcerned with being noticed. And yet, this does not drain Earth of significance. It reframes it. Meaning does not arise from being the best. It arises from being aware, from noticing contingency and still choosing to understand. Earth's awareness is meaningful because it exists at all, not because it exists alone. The universe appears vast enough to hold many such moments of awareness, each shaped by its own conditions, each asking different questions, each finding different forms of understanding sufficient. Some may ask why. Others may never need to. As the journey reaches its pause, no conclusion presents itself. Only an image lingers, countless planets circling patiently, some restless, some calm, each carrying possibilities shaped by gravity, light, chemistry, and time. Earth is one of them, turning beneath a familiar sky, asking whether life elsewhere might be easier, gentler, more forgiving. The universe does not answer. It continues, and in that continuation, the thought remains suspended, not as a problem to be solved, but as a presence to be felt. If life can flourish under conditions kinder than those that shaped us, then awareness may be far more common, far quieter, and far less concerned with proving its own significance than we ever imagined.